2020, day 5, binary boarding. It seems that we've just misplaced our boarding pass, and instead of going up to the gate counter and asking for them to print off another one for us, we're gonna take our phone and walk around and scan everybody's boarding passes to see if we can figure out what our seat is by a process elimination. In order to do that, I guess we've determined that the airline is using a binary space partitioning for the zone and group seating. I don't really know what that means, but yeah, let's see. So I guess it's saying that the first chunk of letters are a combination of F and B. And as each F or B occurs, it tells us whether we're in the front half or the back half of the remaining numbers, which correspond to rows in the plane. And so as you move through all of these, you narrow it down to some row. So yeah, that makes me think that this is just, letters representing a binary number. And yeah, it looks like for the seat in the row, we're doing the same sort of thing. We've got L's and R's. So RLR is like right, left, right, or I guess I don't know what the L's and R's stand for, but yeah, I mean, if an R is the upper half and an L is the lower half, then R's are ones and L's are zeros. So that would be like 1, 0, 1. Yeah, which would be 5. And I suspect something like this would be 44 in binary if this resolved to binary as well. We can check that though. So open up a pry session. And can we like G-sub and say the fronts are zeros, and then another G-sub to say the backs are ones. And then I think if we were to 2i that, it would just be, a decimal number, but if we pass an argument to it, it'll tell it, what's the terminology here? Like what base to use, right? So base 10 would just be what we saw. Base 2 would be binary. 44th. Yeah, 44. So yeah, it seems like what we're dealing with here is binary. So that's nice. And then what do we do with that number? So we parse out the row, we parse out the column. We multiply the row by 8 and then add the column. And that is the seat ID. So there's a bunch of unique seat IDs. That's what we're determining here. And so for all of our boarding passes, we're going to figure out the seat ID, and we want to identify the highest seat ID on a boarding pass. So these problems are getting kind of subsequently more complicated in that they're like kind of adding more and more steps or like pieces of indirection. So for this one, it's like we have to do some parsing to parse the pieces apart. Then whatever method we want to take to figure out what the seat and row are. In our case, I think we can do just the binary thing that I did over in the pry console. And then from there, we have to iterate through them and do some math, and then we have to find the max of those, and that's our answer. So there's kind of like I guess like 4 steps there. Yeah, so let's grab the puzzle input. Welsh or English? I don't know why that pops up. Ooh, got a whole bunch of these. So we'll copy that and we will jump back over to our terminal. Let's get out of there and make a directory for the day. And we'll do part1.rb. And we can stick our input in here for now. Took a second to paste. Okay, let's insert in front of them like that. We'll do a similar block selection. Use the $sign to jump to the end. A, add our closing, double quote, and then a comma. That completes for all of them. So that's our input. And so if I'm just to recap the steps, we need to parse out the row and column codes from the input. Then we need to sort of convert row and column binary to decimal. Then we need to do some maths. So we'll take row times 8 plus column. And then I guess grab the max, and that's our answer. Without max. I think those are all the steps. So yeah, let's start here. Input dot math. So how many of each of these are there? 1, 2, 3, 4, 5, 6. So 7 and 3. So we'll map over each of these. I don't know. Wow, having some issues typing boarding pass. That's what we'll call it. And so the boarding pass, yeah, how are we going to split a string? Yeah, I'm not sure in Ruby how to I mean, I guess we could just do the sort of the regex tricks that we were using in the previous problem. So we could do like captures again. So we could say give us like, you know, the first 7 characters, and then give us the second 3 characters. Dot match. Let me make sure I'm getting the order of the match right. So part 2. No, it's string.match regex. Okay. So that's going to return a match object, and then we're going to want to return the captures, and that's going to be an array with the 7s and the FBs and then the RLs. Oops. Close that, and guess that's the first part of it. And we can just kind of keep piping it along. So for the next thing, we're going to convert the row and column to binary. So we'll map again. And we'll have row, column. And so for row, we will G sub, and we want to turn the F's into zeros. We want to G sub and turn the B's into ones. Yeah, and then do the 2i in base 2. And so I think that'll deal with the row. And we'll put that in an array. Basically be returning a tuple out of this block here. First part of the tuple is the decimal for the row, and the second part of the tuple is going to be the decimal for the column. So we'll do a similar thing, column.gsub, and then the R, the L's, I believe, are the zeros. The R's are the ones, 2i, close that off. So that's our conversion. Then we want to map again, and we get the, I mean, it's just row column again, just in different formats. And this time they're decimal numbers, so we can actually copy this formula exactly. So return that. Dot max, is that a thing? Look at the Ruby docs in line here. Max, yeah, array max. Max 3. Oh, the top 3. Yeah. I mean, this, I think it just knows how to work with an array of numbers. Okay. Okay. Tells me what exit is instead of exiting. Okay. Max, and puts that out. So I'm just using tap because I want to just pipeline this whole thing. It's kind of a silly use of tap, but it lets me kind of, tag on this put statement at the end of all of these others. So kind of mangled those. We'll put them back up here. Kind of the same thing. Okay. Should we give it a run and see how we're doing? 892. So we didn't have an error. We've got a number that sort of seems in a reasonable range. Let's plug it into the input here and see if we got ourselves a gold star. All right, we made quick work of that one. That was fun. Great, well, maybe we'll do part 2 in another video. Otherwise, thanks for watching.